So I want to take some time and just talk about the Linux directory structure and moving around in that directory structure. And you can see that the directory structure is like a tree. So the root of the tree, and of course, in a real tree, the roots are at the bottom. So in this case, the root is at the top. But we call it root, and all of the directories basically come from the root. And then some directories contain other folders or directories. We call them directories in Linux. Um, Folder was a Windows term that came in use, but every user has a home folder, and so when you look at this, you see a home folder and on the far right, and underneath that home folder are user folders. And so each user has their own folder. Now that particular user has the permission to write files into that folder and run files that are created in that folder. They own that and everything that's inside of it. The root user has their own home folder called root, and you can see that's the second one from the left. And I don't really know why there's a Windows folder there in that structure. That just kind of confuses things to me, but it's there nonetheless. So we're going to kind of look at some things in terms of how to navigate. So the two commands here that we see that come into play are printing the working directory pwd and cd. And so we'll also talk about some other files, but we're going to show you this um, to start with. First of all, I'm going to go to my home folder. Now, if I go and I use the cd command to navigate through folders. Now, when I do that, what I will do is I will use either the absolute file path or the relative one. Now, in this case, if I'm going to go to the root folder, it's always going to be an absolute file path. I'm going to use a cd and a slash, and that is the forward slash. That's going to get me to the root folder. Now, I know that I'm in the root folder because I can see the little in blue there, the slash beside that. There's no other folder name there. So if I were to use the list command to list files, I can see that I have what is to me a familiar directory structure here, that looks like the root file system. But if I want to double check and make sure, I use the command pwd for print working directory, pwd, and I see that my directory is indeed the root. Now, if I want to actually descend into that tree, I can actually go into one of these folders and look, for instance, in the home folder. Right? If I again print working directory, I see that I'm in the home folder, but I want to use the list command to list the files. And I see that my user, D. Darden, has his own folder inside that home folder. The interesting thing that happened here is that you notice that when I went into that folder the first time, I had the forward slash home right there before the dollar sign. But when I descended further into that tree, that became a tilde. The tilde is a special character in Linux, and it's a shortcut which stands for your home folder, a user's home folder. So, for one thing, that's how I know who I am. right? I could use the command who am I and see that I'm ddarden. And so once I go into home ddarden, I'm in I'm in my home folder. So the tilde always is a shortcut for home. I can use that tilde anytime I want to reference my home folder. So in place of /home/ddarden, I use a tilde. So the the first thing, the /home/ddarden, is the absolute file path, and the tilde is the relative one. So it's the shortcut. Now, when I look at files, I'm going to go ahead and just list. In this case, I'm going to list all files. Now, the one thing that happens when I list all files is that I get all of them, even the ones that are hidden. Files that are hidden begin with a dot. Files that are hidden begin with a dot, which means the first two files that are hidden are the single dot, which means the current directory, and the double dot, which means the parent folder. So those are again relative file paths. So if I use dot dot, that means that what I'm going to do is I want to actually go into the parent folder of this one. So what should happen is that when I should go into the home folder, and there I am. Now I can keep on going up, right? Because that home folder also has a parent. In this case, root. Now when I look at all the files here, I still see the dot and the dot dot there. But if I go to cd dot dot to go to the parent folder, there is none. It's always root. So in that particular case, that links back to itself. Okay. The other one, dot, it just means here. So if I do cd dot, it's a valid command, but it doesn't do anything but take me where I'm already at. Alright, so again, same thing in my home folder. So I can navigate this way. I can also describe the relative pathway to files. So I could, if I know that there is for instance, if there is a file that's accessible in a folder that's above this one, I could always reference it by using the dot dot and then whatever the folder name and file name is, right? That always what that relative path says is it says go up to the previous enclosing folder and then go back down into another folder and then look at the file. So that is basically a way to use a path or a file path to have the system look exactly where you want it to look for a specific file. Now, one thing that we have to remember is the Linux system is designed not to be a headache. It is designed to be very versatile, very stable, and it is designed to be extremely easy to be very specific with what you want done. So I have a lot of power in how I utilize the system. So from that end, it's designed not to be hard, but to be very easy as long as you know what you want to do. So just a quick look here. That was the CD command. And then the subdirectory is and a lot of times we say subfolder, but that's just a folder within a folder. All right, so I'm gonna do a quick little demo, and make some folders. So I'm going to go into my home folder and I'm going to make a directory called folder 1. Now I'm going to change directory into that folder. I'm going to make another directory called new A, new dash A, new dash B, and new dash C. So what's going to happen is I'm going to actually make 3 directories off of this main folder. And if we look at them, we can see that they're there. And I'm going to go into my new dash B, and I'm going to make 3 more. Now, I have a little command called tree that you may or may not have on your distribution, but I use it on mine because I like to be able to visually see what I'm doing. And so this basically just takes the current working directory, in this case home ddarden folder 1, and it looks at every node that's attached to that and gives me a little graphical view of what happened. So those are the directories that I just created. Now, if I go and I'm going to go into VI, and I'm going to, instead of actually using a instead of descending through the folders, I'm going to just go through and I'm going to say, okay, I want to create a file, and I'm going to start by looking at the folder new B, and then I'm going to go into the folder new 1, and I'm going to make a text document. Okay, and I'm going to go into insert mode and type a document. Press escape to get out of insert mode. And it doesn't want to write. Okay. I'm going to override my error message by qbang, right, to get out. It's probably something I did wrong with my path name. And I will do it that way. Yeah, there we go. That was the incorrect. So again, using the relative path, what I was telling it to do was to go up a folder and then look for new B instead of new B, which is right here underneath folder 1. So if I do my tree command again, look at that. Now I have a new B folder. Inside that is a new 1 folder, and inside that is a document. So I can reference that file and I can look at it. I don't have to be inside this folder in order to actually look at it, play with it, and manipulate it. I do have to have permission to do that though. So if I did cat, now autocomplete works here. So if I type in new, it's going to ask, I'm going to have to complete what I want, and then the only thing there is doc. So I'm just press tab a couple times, and I get that. So the auto completion feature actually is very helpful, right? Especially if I had a lot of directory structures that I was going down. Okay, so and the point. What's the point? The point is to organize files in a very organized fashion, right? So let me give you an example of what that might kind of look like in terms of, let's say I had a project, right? So I'm going to go ahead and I'm going to make a project folder inside this one. So let's say in my project, I wanted to make a folder that contained documentation. Maybe I contained some code libraries. Maybe it also contained some headers, right? Or I could do live headers. Um, maybe I'm going to compile a piece of software and put some object files there, right? So now let's look at the tree. Notice that I'm beginning to flesh out a project folder and have a way to store those files. Now, another thing I want you to see, how many clicks would I have had to do in Windows in order to make that happen? Right? I would have had to right click on a Explorer window, go to new folder, type in the name, maybe my finger hits the mouse and it clicks off of it, and then I gotta re-click on the box and type something in, right? I just created a directory structure that was um, pretty advanced in terms of having the project capability to store and organize data easily in one command. So let me show you this again. I'm going to go back to folder one. Now I have my test folders. I have my project folder that's off of that one, and then doc, lib, headers, objects, right? So it just makes it very easy to organize data. Now I can fill that with any types of data I want. Maybe it's some kind of programming code or whatnot. Okay, so what kinds of files can we have? Now the file that I created in VI was a text document, but I may have some other files that are available. So we're just going to kind of take a look. I'm going to go into one of the special folders here off the root called bin. This is where the system binaries are stored. So if I look at this and I list files, and I'm just going to go ahead and use the capital F switch, that is going to give me a little icon after every file. Now, there's a couple that you see here. One is that that file is the asterisk. That means that it's an executable binary file. And then we have one that is an @ sign. Now that means that it is a link to another file. So we're going to take a look. I'm going to just take a look at the less, and we're going to do ls-f all files that start with the word less. And so I have that little designator after it, and I'm going to actually show detail. So I'm going to say ls-big F and the L for the detail. Any files that start with less. And look at that. So it's something that's a little bit interesting, right? I have these binary files here, but then I have this one. Look at that. So less file is actually a symbolic link that points to less pipe. So when I run less file, I'm actually running the command less pipe. Now, because these files are in our bin folder, a lot of times these files are programs that have manual commands. So if I wanted to find out what that file is, I could run a man and read about it less pipe. Right? It's an input preprocessor for less. So they can change the way that the program less works. So in the less is a pager. So if I were to look at the man for less and use less to view it, less is going to be a kind of a lightweight. I'm not going to have as many features, right, in terms of that uh, program. And this one is more. More is different. More, I can go back and forth. I can search inside that. I have help. So, there's I can use regular expressions. I can load list of files and more. So lots of different things they can do with that program. But that is anyway another program that I could use. Man, more. Okay, what's more? It is a way to view files in the CRT. Okay, so in this case, more and less are binary files that are system viewers, and they're in that file system. So they've been added into the file system, and we can actually see that when I list the files and I use the more as the filter, it shows me that file. And it's just a program that can be run. So when I send data to it, it acts in a certain way. So again, how would I organize these files if I didn't have some type of structure in order to do it? Well, that's what we have now. When we look at our file system, um, we have a couple of different folders here on the file system. One example of a folder that is here is the dev folder. So this is the special devices. So in the special devices, these are basically special. Some are, in this case, the TTYs, teletype terminals. You got TTY 1 and let me list. We're going to go ahead and say, okay, what do you have a number after TTY that is a 1 through 9? And in this case, there's only one TTY that has a single digit after it. There is no TTY 2, 3, or 4. But this is a special device file for the terminal. Um, our our drives and other things are in this special folder. If I press my up arrow, I get access to the last command I typed, and I can look at the F key and see that there's no special symbol after that, right? So it's not an executable file. It's not giving me. It's a special device file. Everything in this folder are devices. Um, in the etc folder, everything in this folder is configuration. So all the configuration files go in this folder. Um, there are special commands in the manual pages. If I did a keyword search for etc or /etc, I get a lot of files that I get a lot of pages about files that are configuration files and how to edit them. So what I can learn is how to actually configure the system using the configuration files by looking at these man pages. Okay, so that's just an example of other things I can do with I can look at in the file system. And of course, we have named pipes and sockets. These are special. Named pipes allow me to process information, send them from one place to another, and sockets will allow me to send data to over a network. Okay, file names are case sensitive, so that's important. And right here, I wanted to point this out in this PowerPoint file. If you happen to look at it, this is 1S here, but that's a typographical error. I don't know if it had a problem converting. That it should be LS. It's always LS. So again, if I want to list files and I want to list the details plus all hidden files, that's ls-al. That will list all of them. It is not a 1. Okay, so that is a typo. But there's basically the file structure um, is is very is very standard across Linux distributions. And we'll look at the file components right here. So this is when we look at this, we see the attributes of the files. Now these are this all of this is standard and it's based on the Linux kernel and how it communicates with the disk. So all of these types of things you will see no matter what system you use. But we have a special bit which tells us whether or not that file is a directory or maybe it's a link. So you notice that the files that are blue here that point to another file or have a bit called L, which stands for link. It's kind of like a Windows shortcut. So if I establish a symbolic link to live, I'm actually going to user live. Okay. Same with live 32 and live 64. Go into the user folder. So if I go into the user folder, and I'm just going to go and use my tree command, and it's giving me quite a bit of stuff. As you can see, that is a deep, deep well right there. There's a lot of stuff in this folder. This is a folder where software gets installed. Right? So this is software that if I run a package manager and actually ask the package manager to install software, it is going to go in this folder. So anything that I have, any package that I have installed or package dependency that's been installed goes in here. That's why it's a very large folder and there's a lot of stuff in it. Okay, so again we'll do lsal. We can see the symbolic links, we can see the directories, and they show up as D. The other bits there on the file are the permissions. So you have the ability to read, write, and execute files. And I have 3 groups of those: read, write, execute, read, write, execute, read, write, execute. So the first set is my user, or my owner, sorry. The second set is my group. The third set is anybody or the world. And so the world is that last set of 3 permission bits are usually the most restrictive. And then I have the number of links to the file. And I'm going to go back. I think I never went over to my command prompt here to show that again. The number of links, the owner and the group, my file size, the time, and the file name. That is my list of details that I have. Now, there are other data that come in that file, right? So that's not all of it. That's just the most relevant information. But there's other data that can be in a file. Okay, and then we have this idea of wildcards. So when I have a wildcard, in general, my wildcard is going to show what actually is if I want to show all files or just some files, right? If I want to filter them out, the wildcards are going to be probably one of the most useful things that you get out of using the command prompt. Is that I can use a asterisk to complete my file name, or I can use character classes. So as you can see here, these meta characters are character classes. Now, this is going to be helpful if I am maybe automating some things. So let's say I want to look for specific components and I want to generate a list of files with that share these common letters in their file name in a specific position. And then I want to do something with each one of those files, either delete them, touch them, update them. These are going to allow me to have a lot of control over how I access, use, and otherwise look at files. So we basically have every situation here. I could match a set of letters, I could match a range of letters, or I could basically take that range and invert it with the bank. We don't usually say exclamation point in Linux and other IT world. We say bank. So that exclamation point is always read bank. And in this case, it means not. But a lot of times, what will happen is you will use a caret symbol, which means not in logic. But in certain cases in Linux, the bang symbol actually means that the set is inverted. Right? So in this case, it does mean not. Okay, then we have a couple of commands here. So the cat command is the concatenation, right? When we actually type that command out. And then we have head and tail, where we can look at the first lines and last lines. So if I had a log file that was being produced, I could use head. Normally I wouldn't use, maybe I would use tail. Okay, so I would use tail, and what tail would do is would actually give me the last lines of a file. So if I had a log, system log, as things were added to the file, the tail would actually show me the last line. So I could actually read something that's going on and view it while it's happening. Oh, I have a log file here. And at first I want to look and see what files I have. So I'm going to go into the var log folder and see what files are there. What I usually would have is a syslog file. Okay. In this case, I don't know if I have that. I may have it in journal. No, I don't have that there. Okay, there's a lot of information in this var folder. So what we can use is the tail command, and we'll look at the last log file. And that file is empty. So it says, oh, it has some data in it. How big is it? 292 kilobytes. What's in there? A whole bunch of nothing, right? So, these are the way that I would use these commands to actually examine this data, right? I'm looking for my syslog, which is pretty weird. I'm not sure where it is on the distribution. So it should be in var log syslog, but I don't have it. Probably because I'm not really running a real distribution. So if I was running something else, I would have it in. I would have a syslog file right there, which I could use. So we'll use tail and look at dpackage. So notice that what I did when I ran tail is that by default it showed me the last 10 lines. So the reason why that would actually be helpful is that I could just really quickly look and see what's being added to the end of a log file. And we have some log entries from about a week ago, so they're a little bit older. Um, I could also use tail if I, for instance, that would actually continually monitor that file, right? And I could see whatever I wanted. Now, if I wanted to use that and put the new lines that were added into another file, I could always do that as well. So the idea is that if I have the file system here, I have control over how it operates and where data goes. So that's a very powerful tool that I can use. But it's just an overview of the file system so you can get an idea of it. Here's my more and less. Here's some other utilities that I can use. And then we get to regular expressions. So regular expressions will be something that you want to look at in the text. You definitely want to check that out because regular expressions can be very useful. And there'll be an extra several pages there to give you an idea of regular expressions. Now, mastering regular expressions is totally different. So there are some basic regular expressions that you can get to be familiar with, but it may take a while to really think about how to master those regular expressions. Um, but this is an overview of Module 3, and I hope that you read the text and get more familiar with some of the other commands.